Good afternoon, ladies and gentlemen. Welcome to this Hudson Institute video conference on emerging 5G technologies and their disruptive impact on innovation and competition. I'm Tom Duesterberg. I'm a senior fellow at the Hudson Institute, and I work somewhat on these issues. I have a very distinguished group of speakers lined up who know a lot more about this topic than I do. So Hudson thanks all of them for being willing to join us. These new technologies that we're going to be discussing are variously named as virtual networking, open RAN, radio access network systems, and other related names, but they essentially redound to replacing largely hardware, single-purpose pieces of equipment in an integrated, vertically integrated system with open standards for all players to be able to participate in the system and largely replace many of the specialized hardware products with software products. It has promised to cut costs, be more flexible, to change and adapt to new technologies, and more open to app suppliers and software providers, and hopefully can be more secure than some of the existing systems. Our goal is to elaborate a little bit on the technology to give a good sense of how it's being applied in real-world test cases, both by telecom operators and by private companies, to give a sense of why it makes sense economically and why it's a fairly radical change from the existing systems. And finally, to give some sense of who the main players are in developing these new technologies. And I would just note that many of them, including the two companies represented here, are American companies, some software, some hardware. There are also Japanese companies, European companies, Korean companies that are major players in this new field. So let me introduce our panelists and get right to it. Going in alphabetical order, we have Doug Brake, who is the Director of Information Technology and Innovation Foundation, ITIF's work on broadband and spectrum policy. He writes extensively and speaks extensively, talks to Congress, testifies before various agencies in Congress on these subjects. He serves on the FCC's Broadband Deployment Advisory Group. Doug is a graduate of the University of Colorado Law School and McAllister College. He previously worked as a research assistant at the Silicon Flatiron Center at the University of Colorado, and interned at the FCC as a Hackfield Scholar. Next, we have Bob Everson, the Global Director for Mobility and 5G Architecture for Cisco Systems. He's responsible for designing, defining, and developing industry-leading 5G solutions. Bob is also the head for the Open vRAN ecosystem. This initiative was formed to accelerate innovation in and around the radio access network and to accelerate the adoption of open virtualized solutions. Bob's had 25 years of experience in various capacities for Cisco. He's a graduate of Oklahoma State University. Finally, we have Stein Lundby, who leads Qualcomm's corporate technology strategy function to identify disruptive technology shifts, develop strategy and business cases, and work with executives in major operating companies to drive implementation. Stein has worked at Qualcomm since 1997. He holds over 100 patented inventions in mobile and wireless technologies, and is one of Qualcomm's leading technologists and inventors. He also teaches as an adjunct both in San Diego and around the country. Stein has a bachelor's and a computer sciences master's degree from the Federal Polytechnic Institute of Switzerland, also a master's in EEE from Duke, and an advanced degree in wireless technology from Eurocom, and accreditations in strategy from the Harvard Business School. So each speaker will have 5 or 6 minutes to give opening remarks, and I've asked Stein to lead off the discussion. So Stein, over to you.
Thank you, Tom. It's a pleasure to be with all of you today and to discuss this topic, which I've been working on for several years and is of great interest to me. You've mentioned many terms, and there are many terms, and this often can get confusing hearing all these various technical terms. But the bottom line is it's actually not a technology shift. It's a technology shift it's a technology that actually helps more an industry shift. And the shift is really around how industries evolve. Typically, industries get established as closed, proprietary, vertically integrated solutions to be able to meet the performance requirements and the feature requirements that the customers need to be able to make it work. So you can think of, for example, healthcare started as an integrated system. You can think of construction industry. You can think of the computer industry. The telecommunication industry started like that. And then eventually there's a certain time where the industry reaches a level of maturity where it goes into a modular state. In the modular state, the functions of the various elements in the industry are better defined. And then it's better to actually have different companies that play the various roles in the industry. So, for example, in healthcare, now we're in a state where one company takes care of billing. Another company takes care of the hospital itself. Another company takes care of the surgical instruments. You may know, but in many hospitals, typically the surgical instruments don't belong to the hospitals or to the doctors themselves. They're brought in, and so on and so forth. And same thing happened in the construction industry, and same thing happened in the computer industry. You may remember the time where we had IBM, Wang, DEC, and all these other companies who made vertically integrated solutions where they made their own processor, they made their own operating system, they made the software on top of it, they provided their own screens, their own keyboard, everything was from the same vendor. And if you had an IBM machine and you needed another keyboard, you couldn't go and take a DEC keyboard and put it onto a Wang keyboard. You had to go back to IBM. And so it was really an industry that was centered on and establishing yourself, getting a connection with your customer, and then maintaining a vendor lock-in so you could initially start selling at low prices and then make up all of our services, upgrades, you need more memory, and so on and so forth, right? So we've seen a similar type of evolution or similar type of establishment in the telecommunication industry. If you remember the first cell phone systems, right, back in the day where they were Motorola launched the first cell phone system in Chicago. If you look back at the history, it's told that a lot of people in Motorola thought it couldn't be done. And actually, the first cellular system was a demonstration for those who believed in it to show that it could be done, but those who didn't believe in it, who thought that the two-way radio system was the way to continue going, to prove that it didn't work and you'd have to abandon it. So the technical challenges of developing these products have been extremely, extremely high. And it required you to do everything yourself, or have a very tightly integrated ecosystem, have custom parts. So the base stations had custom processors. They even have their own language and to program these in some organizations. They had their own protocols to communicate with each other, and so on and so forth. And the whole network tied in extremely tightly together to be able to work. Then after that, we had 2G, then we had 3G, then we had 4G. So it didn't stop, and the requirements kept going up and up and up. And so the only way to do that was to maintain proprietary closed systems. Now we're reaching a point where we're in a very interesting situation. With 5G, yes, it advances the performance of over 4G, but it's still the same modulation. It's still the packet-based. It's still a lot of what 4G established. And that's why we were able to deploy and develop 5G so fast. Then also the other thing is 5G calls for new use cases. smaller networks, larger networks, modifying a network on the fly, adding more services and so on. So it's calls for much, much greater flexibility. And that's where this whole movement to these new types, Open RAN, disaggregated networks, virtualized networks, all refer to the same thing. It refers to shifting the industry from an existing product where it's one monolithic network to a state where the product is a set of modules, each of them supplied by a different company. And the technologies involved in that are software technologies, the standards involved, the open standards, and so on and so forth.
Okay, well, let's go to Doug Brake. Doug has written an excellent comprehensive report on 5G, including important updates on where we stand with network virtualization technologies. And I hope that we can start to talk a little bit about actual applications of these new ideas in the real world. So Doug, over to you.
Sure, yeah, thanks so much, Tom, and thanks for Hudson for having me. Really appreciate all the work that you've been doing in this area. It's fantastic to be a part of the panel. So I'm Doug Brake, the Director of Broadband and Spectrum Policy with the Information Technology Innovation Foundation. We're a small nonprofit, nonpartisan think tank in Washington, D.C., focused on innovation, productivity, policies that we think will, help economic growth and, in the long run, human flourishing. We've been ranked, very proud, and I'm contractually obligated to mention that we've been ranked in as the top science and technology think tank by the University of Pennsylvania for several years running now. We're quite proud of that fact. And as Tom mentioned, I recently had a big 5G report that delved into a number of these issues. So glad to be here. So yeah, it is kind of listening to Stein really break down a lot of these issues. It's fantastic to learn from him. It is can be quite a alphabet soup of different acronyms in the telecom space. So I think it's worth kind of slowing down and really being very clear about what we're talking about. When we talk about Open RAN, right? We're talking about when we're talking about the RAN, the radio access network equipment. We're talking about the equipment, on top of cell towers, on top of buildings, that really serves as a link between your cell phone going over the air, connecting with that equipment, and then where the wireless goes wired and feeds into the rest of the network. So we're talking about that little portion of the network. It's a critical and really expensive part of the wireless network ecosystem. I've seen estimates 60–70% of the total cost of ownership of running a wireless network is in this radio access network equipment. So it's a big part of 4G. It's a big part of 5G. When we talk about Open RAN, I think the best way to think about it is to think about the interfaces between the component parts of this equipment. And really the most important interface, as far as my understanding is, so the proper technologists maybe will correct me, but my understanding is the most important interface is between the radio, the actual antennas on top of the tower, and the baseband unit, where the signal processing is done, that actually does the translation between a signal that can go over the wire and one that can go wireless, if that makes sense. This goes hand in hand with some of the virtualization technologies, software-defined network function virtualization. If you're able to take some of those equipment components, some of the components of the RAN, and run them as software, right, virtualize them over sort of generic, low-cost commodity hardware, you can dramatically lower the cost of the actual equipment, but then also really increase your ability to innovate and roll out new services by iterating more quickly through software. So tremendous opportunity. As you mentioned, there's some important players, a lot of developments. It's a very fast-moving area of technology. Some of the key bodies that have been sort of developing the standards and developing the open specifications of these interfaces. One you may see quite often is the O-RAN Alliance. Formed, I believe, late 2017. It's largely driven by service operators, but it's a big tent, has a lot of different companies, a lot of small companies interested in this place. notably on the equipment provider side, on the vendor side. Nokia has been involved for, I think, since the beginning, and Ericsson recently joined the organization as well. But Huawei, the sort of third major equipment vendor, has sworn off this project and seems to be somewhat skeptical of this open RAN more generally. Overhand Alliance is not the only organization working on these specifications. One example is the Telecom Infra Project, or TIP project, that has been led by Facebook, that's been looking to do open source hardware, open RAN specifications for quite some time, largely in a hope to drive down the cost of these networks in countries around the world. There are a number of operators looking to make this transition. One of the biggest and sort of most exciting opportunities in the space is Vodafone. Recently offered a large RFP, a request for quotes, I guess, for this open RAN technology for its entire European footprint. So we're talking about 14 countries, over 100,000 cell sites. So this is potentially a big deal. Whether or not they go forward with it, to what extent the proposals they get are worth exploring is, I think, still to be determined, but a very exciting opportunity. In Japan, the company Rakuten, it's an IT company that's looking to focus purely on this sort of mode of open and virtualized systems for building a new greenfield. I think they're first focusing on 4G networks, but a new entrant into the Japanese market, which is very exciting. Reliance Jio in India is also a very early mover in this direction, this general direction towards more virtualized systems in its network. They acquired a company, Radisys, years ago that has been a focus, one of the key integrators in this space. And interesting, recently, Facebook actually took a large stake in Jio, I think a 10% stake in Jio, which shows, I think, a really interesting trend in how some of the tech and telecom world is increasingly merging. Here in the U.S., I mean, a lot of companies, a lot of the operators are interested, focused on virtualized systems generally, but I think one interesting note is Dish, as part of their agreement with the DOJ, as part of the Sprint T-Mobile merger settlement, is promising to build a 5G network, and they're saying that this will be largely focused or entirely focused on these sorts of virtualized and openly defined radio access network equipment. They hope to make a lower cost and innovative system. So I think an interesting opportunity to watch. A number of the large AT&T, Verizon, and T-Mobile as well are interested in this stuff, particularly AT&T. I think it's important to note, right? This also, I mean, there's a lot of interest in the market, but there's also, especially quite recently, a really strong uptick in the interest in the policy world in DC. Yeah. A lot of conversations about this issue. And I think, I mean, for a number of different reasons, right, that we've touched on, it's more innovative, faster pace. It can help increase U.S. competitiveness, both in the actual provision of wireless networks and the services that they're able to provide through a number of different, verticals throughout the economy. But also, I think a really important, manufacturing opportunity as well, I should note. But really, honestly, I think driving a lot of policy conversation is all of the focus on Huawei and the potential security threat that they pose, especially the long-term threat to innovation and control over this equipment market. So if we're able to change the terms of the market through this transition to a much more open, more modular, as Stein put it, I think described very well, it would be a much more difficult area of the economy for Huawei to corner long term, right? It's like we're down to 3 major players in the sort of traditional integrated systems of radio access network equipment: Ericsson, Nokia, and Huawei. Nokia is on some shaky financial footing. Apparently, there are some private equity companies that have been circulating, at least the reporting goes. And so we're in this situation where we have one equipment provider that is not trusted by the government or U.S. operators. And so we may be in the future subjecting ourselves to a voluntary monopoly with no real good alternatives, unless we're able to really change the terms of how this this equipment operates, and that's where Open RAN comes in. I've got a number of thoughts on some of the policy options to move forward, but maybe we can hear from others and get into that further in the conversation. Thanks again, Tom.
Okay, thank you, and we will get back to that in the second half of our conversation. So, Bob, over to you. Cisco is a major player in a lot of the IT sector. Why don't you give us your views on Open RAN plus the role of Cisco?
Sure. Thanks, Tom, and thanks, everybody. Yeah, Cisco has been in the mobile space for quite a while, and we've been inherently multi-vendor really from the start. Some may argue that we had to be because we didn't make a radio, but the reality is that from the early days we've been operating in this multi-vendor environment and seen the importance of open interfaces, and also seen the challenges where interfaces aren't open, whether it's the actual interfaces between the devices or the management interfaces, because that's an important control point that I think the legacy vendors hold on to there as well. We've been in Open RAN, and we sort of were one of the early ones to drive this movement as we founded our Open vRAN ecosystem about 3 years ago at this point, back when people were really shaking their head a lot, thinking that this was not going to be a real development. And now, it's great to see the progress. Maybe expanding on some of the things that have been said earlier, what we have here is we have a merging of the telco domains and the IT domains. And it's really interesting because there's great innovation and there's great technology from both sides. So I'm not a binary person where, it's one's good, one's bad. There's a lot of good. There's been decades of innovation in the telco space, which are extremely valuable and have helped the operators get to the point where they are right now. There's also been a lot of innovation over on the IT space in understanding how to build software systems and how to develop much more agile solutions. And so as we bring those together, it's inherently beneficial for the telco space and for the operator space to help them focus on solving customer problems and also solving some of their own challenges. Solving customer challenges around, how do we innovate on new services? And from their standpoint, how do we take cost out of the network? How do we make, more, efficient from a CapEx standpoint and also from an OpEx standpoint? As we think about it, the products are certainly important and they're an important part of it. But I like to look at it as a 3Ps sort of thing, where it's the products, but it's also the people and the processes. And as we evolve down this path, we see this evolution. Rakuten's a great example. We partnered with them on this network that they developed. And I like to call that the 0 to 1 moment for the industry, meaning that before Rakuten really made that bet, nobody had done this in any kind of scale other than, kind of some lab tests and maybe some really limited things. And so Rakuten made a huge bet here. With a lot of innovation and leadership and willpower, has launched the first fully virtualized network. And along the way, you figure out a lot of things about what it takes to launch a network like that, what it takes to operate a network like that, and really, plows the way for the broader industry. If we look at some of the things that were accomplished there, besides the fact that they deployed this network, they have moved the base station installation process to an automated process where, essentially now the tech goes out there and hangs a radio on the tower, plugs it in, and it phones home and is automatically brought up across the system. So, it turns a process that, best case is many hours, 6 to 8 hours to, in some cases weeks, depending on, what has to happen on the back end, to something that's automated, which looks much more like an IT type process. And it uses software-based automation. So I think that's an example of the power of moving these things to software. If we shift over, I think Doug did a great job of explaining the difference between open and virtualized. And expanding on that, when you look at the openness in the interfaces, and that's really, there's the front haul interface, which is last interface between the radio and the equipment, really. And so that's a really important interface that's been closed for many years. Since the beginning of time, it's been closed and is now starting to open up. And I just actually went through an assessment with some of our partners around the open radio ecosystem and what's available out there. And I'm happy to see that we're seeing radios across a number of different bands being developed for that open interface. Because it's one thing to come up with an open interface spec, but then it's another thing to see the radios appear. And so we're seeing, low band radios, we're seeing mid band radios, and we're seeing high band radios as well in millimeter wave. As you get more options out there, then that gives the customer that optionality for both picking the best product to solve the problem, and also for supply chain diversity, to allow for multi-vendor solutions and to prevent, I think, the fear around a particular vendor dominating a supply chain there. And as you get scale in anything, it's like any business. As you get scale, and you can get economies of scale, and so you start to see cost decreases. You can build radios that are no longer, essentially bespoke to a RAN vendor and a customer situation. They start to become applicable to multiple different customers. On the other side of it, the virtualization again, which is really separating the hardware from software, and so it's more of the vertical integration, I guess, or vertical innovation. As you do that, you get this programmability and you get the agility to deliver new services in new ways. But the other thing that we're getting that I think may be underappreciated right now is you get to ride a new cost curve, a new declining cost curve, which is the COTS and general purpose compute cost curve. So if you look at an existing mobile network with the integrated baseband and all that, you could argue that it's a pretty cost-effective system in itself because it is dedicated hardware, and so it's ridden a cost curve for quite some time down, and hit a point of sort of stasis in the market. As we move this to virtualization, not only do you get the programmability, but you get to ride that that x86 cost curve and the x86 innovation curve. So you have the innovation continuing to go up and much more agile, and you have the cost curve continuing to go down as we innovate around that, because there's a much bigger ecosystem that's leveraging that technology. It's not just telco specific. So I think that's some of the real power here, and as we move towards 5G, there's an opportunity for customers. If you look at the telco market, there's a tremendous amount of inertia that's built up in this, because if you look at the architecture of the way mobile networks have been built for decades, it's essentially the same. I mean, don't get me wrong, there's been a lot of work done in 3GPP and a lot of great innovation across different levels of the stack. But if you look at the basic network architecture, it's essentially the same. And so as we move to 5G, I think operators have a choice to make, whether they want to just add 5G to that existing legacy and extend it further, or if they actually want to transform the network and be able to transform the experience during this time to give them that, that optionality, that flexibility, which is going to be, incredibly important, which we can get into later on, maybe with some of the new use cases with 5G that are expanding quite dramatically.
Okay, thanks, Bob. I'd like to focus a little bit more on the economic viability of that you started to touch on, Bob. And Stein, I know you've done a lot of thinking about that. And one of the questions that actually Bob alluded to was that existing systems involve a lot of embedded capital as well as embedded technology. How can we think about the economics of moving to a fairly new type of system with a bigger variety of vendors, both from the point of view of the vendors, the makers of the equipment, but also the operators, the telcos, that are going to be the major way that the new technology is brought to the consumer? how do we overcome this this legacy problem, economic legacy problem, and make the economic offerings attractive compared to just making a transition using existing equipment to go to 5G?
Yeah. So the first thing is, I think Doug pointed out also, in this new modular environment where you've got one company that provides each portion of a system, the competition becomes much greater. The prices start going down. The quality and the security and also the feature richness of the products becomes much greater. So naturally there, you're going to have some cost savings. We've seen in the Rakuten networks, we've heard numbers quoted such as OPEX requires 10 times less resources for OPEX for maintaining your systems. In terms of investment itself, there's some numbers between half the price, a third of the price. Now, whenever you introduce a new technology and start something new, it's my opinion that it always costs you because there are some switching costs. We look at AT&T's virtualization, right? They did their transport network and part of their core network, and they were a leader in that space. They were really a trailblazer. And it has cost them. It's cost them in retraining their workforce. It's cost them in adapting their procedures and their software and everything they had, the procurement processes. But after that initial cost, then you start getting some savings and you start getting increased flexibility. Now, when we're talking about existing deployments, you can see probably you can think of three scenarios, right? The one scenario is a Rakuten or a Dish or another type of player that comes in and doesn't have a network at all. And those type of players in that case, they've got the choice between doing a Me Too, buying from the same vendor as their competitors, same two or three vendors, depending on where they are, installing the same technology and the same everything, knowing that their competitors are ahead of them in deployments, in market cap and customer acquisition and so on. It becomes very difficult to really get ahead. There, you've got no problem with integrating with existing equipment. You might as well just go with the new architecture, right? And we've heard Dish said that they're going to go all out in this new type of architecture. We've seen Rakuten go all out, and I think we'll see some others. The second scenario you've got, so there's the first scenario, which is the most green, which we call greenfield, right? The second scenario is an existing operator that needs to extend its coverage. So we saw either upgrade its equipment or extend where it actually wants to cover it. So for example, in 2017, I believe we saw GCI Alaska, local operator, and they were deploying virtualized network equipment, so Open RAN systems. We saw Telcel Mexico and the cities of Mexico City deploy that. We're seeing now Airtel is deploying also, and it's been for at least has been deploying since last year. And that's where you extend your coverage and you just have to connect into your existing network. And the connections works fine. I mean, of course, there are some compatibility issues you have to resolve connecting into legacy equipment, but it works. And then the third scenario is you have an existing system and you want to replace it. Either because you have to replace it. For example, the rural operators in the US have got a requirement, those who use ZTE or Huawei equipment have a mandate to replace, or because you've decided that you want to start anew. And we have seen operators now coming forth, I can't give some names unfortunately, who've actually looked at their architecture and found that it would be easier for them to just start anew because they've got so much complexity in their systems. Of course, we've also got some operators such as in the UK who now the UK is banning Huawei and they're going to have to try and remove their equipment and replace it. So we often talk about the term rip and replace, and it sounds like you're going to have to take a wrecking ball, a bulldozer, and just take down the tower, and all the costs are going to start from scratch, right? And that's not really the case. A tremendous amount of the cost and complexity of deploying a network is acquiring the sites, getting all the neighbors and the churches, the schools to agree and the neighborhoods that they're actually going to be able to put a site there, pouring the concrete, bringing in the wiring, electricity, bringing in the connectivity, negotiating with the local connectivity providers, setting up the antenna, setting up the tower before that, getting your specialized people climbing up in the towers and bolting stuff on it, creating the cabinet at the bottom, putting in the power, the backup power, backup batteries, and so on and so on. There's a tremendous amount that goes in there, right? All of that in the rip and replace scenario, so-called rip and replace, can be maintained. You do not need to change the antenna. You do not need to change your site. You don't have to change your towers or poles or whatever it is. You don't have to even change your cabinets. You don't have to change your power supply, your backup batteries. You don't have to change any of that. The only tool you need to change is the baseband part. Use the same connectivity, same backhaul router and everything. And you replace it by either you remove it and you don't have one anymore on site, like the architecture that Rakuten has been using, or you've got a local computer, an outdoor grade computer, like for example, has been used in some trials by Telecom Italia, which are smaller, so you pay less lease if you're leasing a spot, and use less power, so you pay less power and you've got less cooling requirements. So you can do this in a very gradual way, in a very cost-controlled way. Now there have been some, so it's not to say that everything's easy and you can just, it's no problem. There have been some pretty bad, some bad stories, in particular when people were virtualizing the core network, which is kind of more the protocol backend of of a cellular network, right? The problem is that it offers you so much flexibility when you've got a system where you can pick and choose the various vendors, right? That it's fairly easy to also set up bad systems, right? We've heard of some operators who've been downloading open source software off the internet, tried to install it themselves, thinking this is going to be work great. It works really great when you've got very few customers, right? When your system's not overloaded. But then suddenly when you start loading your system more, and you're at peak hour at 5 o'clock when everybody's driving home and they're on the phone calling their spouse to see, either to keep themselves entertained or to ask what they should pick up at the grocery store on the way home. And suddenly this seemingly free system or very low custom system does not work does not work well. So the point is, you have to be careful. You have to work with companies that are trusted, that you can trust, that can actually deliver on coming up with a solution. Or if you can't just work with the vendors individually, you have to work with an integrator, one company that takes care of orchestrating all of that. And Cisco has been playing that role. For example, NAC has been playing that role in other deployments. We've got IBM that's put itself forward to play that role also. We've got WWT, which is a big American integrator that's made an announcement that they want to play that role. So many companies are realizing that's an important role. The orchestrator, the person that takes all these various modules together and offers a quality system, a bit like a general contractor in a home or in a building that you're creating. That role exists. There are people very qualified to play that role, and they can help operators, and whether it be large or private entities who want to have their own private networks, set up their systems in a very careful, cost-controlled way that is going to be future-proof.
Okay, thanks. I'd like to ask Bob and Doug if they'd like to comment on that, and maybe reflect on the statement that Attorney General Bill Barr made 3 or 4 months ago, that this type of technology was just pie in the sky. And as far as I could tell, he meant that it couldn't really accelerate the U.S. deployment of 5G technologies, nor provide a viable alternative to Huawei technologies, which are let's face it, the leading systems that are being built right now. What do you guys think about that argument, that it's too far off, it's not economically viable enough?
So I can appreciate where he was coming from in that statement. Probably, I think we're at an interesting time in the market where you see a major technology shift like this happening. It doesn't all happen at once, And so the transition, and I think I mentioned this earlier, the transformation, it's not a binary thing where it's either all one or all the other. And I think Steen talked about it pretty well, as there's multiple different ways that operators are going to implement this. But the thing that we have to challenge ourselves with, and every time you hear a statement like that from a vendor or from somebody in the in this broader ecosystem, I would suggest to peel back a little bit further to understand the motivation, because it is very important for these are large, complex systems. And what we've essentially done when you virtualize and open up this network is you've taken something that's in a box and you've split it apart and you've extended it across a network. And so certainly there is, that's not a completely trivial task. And so we should not, even try and trivialize that and oversimplify it. But on the other side of things, that these are things that we've been doing for quite a while in other domains. And I would say that one of the things that made this a really natural fit for Cisco is we've been involved in virtualization since day one. When it started in the data center, it started through the network, and we've been through transforming legacy systems. I mean, if anybody can go back to the IBM SNA days when the mainframe and Mini was very much a closed system, and then that was broken apart. That's going way back. But there are a number of different examples where you see these legacy systems that have a lot packed into them that transition, and it doesn't happen overnight. But the important thing when you hear that is to peel it back and say, okay, what's the motivation here? Is it to try and maintain status quo, saying, oh, that's dangerous, that water's hot, don't dip your toe into it? This is the only way to do it? Or is it wise caution that we don't get too far ahead of ourselves? As we see it, there's a lot of capabilities. Obviously, Rakuten is deploying a network. Steen went through a bunch of customers that I won't restate those, but there are a lot of customers that are doing this now and are moving forward and validating it in many different environments. We are also working from an SI standpoint with some partners, and Steen mentioned the one that we announced with WWT about 6 weeks ago, I guess, to integrate US-based solutions. And so there's a lot of work going on there. And the important thing that I see is we need to keep this moving forward, because there's so much inertia that, if we're not cautious about when statements like that are made, they can actually, cause a backslide on a lot of the great progress that's been made.
Okay, Doug?
Yeah, a lot to agree with there. Absolutely. When Bill Barr made that statement, I was a little disappointed to hear, but also I do think he has a point and a good grasp of at least some of the dynamics. To my mind, so much of this policy issue comes down to a question of timing as we're going through. Right, it's like we're going through this transition to a more virtualized system, to more open radio access network equipment, and we're also going through this transition from 4G to 5G, right? And it's like those things maybe don't entirely line up completely, at least not for everyone, right? For all the vendors or for all the operators. I mean, and I worry sometimes that I mean, maybe not specifically in Barr's statements, but some of the other conversations I hear around town, there's sometimes a conflation of different risks, of different concerns that I think can lead to sometimes some poor policy recommendations, right? It's like we have this short-term security risk, which represented by Huawei, right? If we were imagining allowing a large portion of U.S. critical infrastructure to be run on equipment provided by a company with at least questionable ties or some jurisdictional control over one of our primary geopolitical rivals, right? It's like there's a short-term risk of the actual security of the equipment itself. And to my mind, it's like that is relatively easy to solve by just not using Huawei equipment in the United States, right? That's relatively easy. I think harder, more challenging, and to my mind, much more important concern is the long-term risk if this market goes, continues along the same sort of integrated non-modular way that it has been for so long, and Huawei continues to grab more and more market share, and it sort of tips the entire global market in their favor. I think that is the sort of long-term concern or risk that this move towards more open and modular and virtualized systems is much more effective in countering, right? And so Bill Barr might be right that there is a performance hit, that this isn't ready for prime time tomorrow, and it's going to be a gradual transition. But at the same time, it's like the security risk that this technology transition is countering is on a longer time scale as well. So I think there's some truth in what he said, but I strongly agree with Bob that putting those statements out there too strongly risks encouraging inertia in this transition. So I think I'm more interested in the policy options to sort of drive the transition forward faster.
Yeah, and if I can maybe just go out of order just for a second, sorry, but just to build on that, I think there's always risk in change, right? And I think it's much more tangible for people that, it's much more recognizable when you see the risk of change. But there's enormous risk in status quo.
Yes.
And I think it's an underappreciated and maybe underrealized risk that, as I said earlier, the mobile network architecture that's been very successful to date will not be the one that drives success in 5 years. And while it's comfortable to kind of stick with that, and it's comfortable, for many reasons, right? And completely understandable, human psychological reasons, right? Of there's that comfort factor. But the reality is that with 5G and with all the new players that are coming into 5G and the new services that are going to be required, because remember, 5G is going to provide consumers, lots of great benefits, right? Faster speeds, and there's more coverage because there'll be more spectrum out there and all that. So not to minimize that, but 5G has largely been defined around services for enterprises and industries and more differentiated services. And in order to compete in that market, it's not just about turning on a 5G radio. You need that agile infrastructure. And if you don't start building it today, as you're spending the money to deploy the 5G infrastructure, then you're going to have a whole other churn cycle that's going to be really uncomfortable 2 or 3 years down the road. That makes it much more difficult to be competitive.
Yeah. So yeah, just to add to that, I'm not sure exactly what the context of the comments are, but certainly for the entire world to converge to start using this new architecture will take some time. I mean, there's no reason for many of the operators to just rip and replace their existing equipment. What is a fact is this technology has been used commercially since 2016 on commercially run systems in Telecom Italia and in Alaska, systems that are fairly large systems. Then now in Rakuten, we've got systems that are equivalent of essentially a large Los Angeles type of city, or significantly bigger. And by the end of this year, it'll be the equivalent of a small European country. And they work. You can go to Japan, you can buy service from Rakuten. We've had our own people in our offices, Qualcomm offices in Japan do this. It works. And yes, you pay half the price of service with about half the price than you do if you get service from any of the other Japanese operators. Now, the optics look a little suspect because you think, well, here are these large companies who are making dozens of billions of dollars a year, who are serving this existing market, right? Who are putting in $15 billion combined of R&D a year. And you're telling me that these startups that are venture funded with the help of a few other larger companies like Cisco and so on, some departments of Cisco, it's not like the entire Cisco is behind it, is able to actually come up with a competing solution? Well, let's look at our history, right? Back in the 1980s or so, IBM had 400,000 employees and was making revenues that was equivalent about today's $150 billion. And you had some guys in the garage making microprocessors, right? Or essentially a small company called Intel at the time. And they were going to make a microprocessor competing with IBM's big central research. IBM had like was reputed to have all the smartest brains in the world working for them. And then you had a bunch of young people making an operating system, and they're going to compete against IBM's offering. And then you had these Cisco, like, little kids playing around doing some networking here. And then you had Oracle making a little operating system, and then you had Western Digital making a little hard drive by themselves. And it looked ludicrous to consider that these little players scattered around would somehow be able to compete, well, not even compete, but even make something comparable to this big giant, this shining company that was IBM at the time, that had offices worldwide, that was established, that was a trusted supplier of so many enterprises throughout the world. Now look, I've been involved in the space industry, right? Like about 10 years ago, right? SpaceX started appearing, right? And the stars won't be right. This guy was making an app, this PayPal, right? He's making an app, this Elon Musk guy. That's okay. I can make an app. You're okay. You can make money. You were lucky. You made a lot of money. But he's going to make a space rocket and launch satellites. And then what? He's going to actually launch astronauts. And you're saying that NASA is actually going to outsource the launching of their astronauts to this startup guy, this little silicon.com guy? That's ridiculous. Did you see the budget of NASA? Did you see how much money these people are putting into it? They're like playing around with, like, they're little software people. They're never going to be able to launch a rocket. And look what happened yesterday. So yes, if you look at it with the wrong optic, right, you can say to yourself, that's absolutely impossible. But if you look at it with the right optic, right, from a disruptive perspective, from what the potential is, what it actually adds up to, you see it as entirely possible. And this is what the United States has done again and again. This is the power of America. And I've got no doubt that we can do it again. We've already done it. I mean, as I was saying, it's been done since 2016. And I can completely see us having the capability of scaling this up to become a complete revolution and moving the industry forward, leveling the play field, bringing opportunity for innovators from throughout the world. There are tremendous, talented, small companies in Europe in this space, in Paris, in Italy, in Germany, in the UK. There are some startups in India. They've already been partaking. For example, Inouye is one of them that's been partaking in the Rakuten network. It's become a supplier, a startup, a tiny startup from India. There are talented people in Asia. There are talented people everywhere. And this opening of the system, this modular approach, now allows national innovators to be able to partake in this system rather than nations just buying a wholesale network that's closed and integrated from one large vendor and having very little opportunity domestically to either partake in the supply or to build on top and create new use cases, new capabilities, self-driving cars, smarter factories, robotic networks, portable networks, field networks, and so on.
This historical perspective on innovation and disruption is fascinating. We got about 8 or 10 minutes left. I have 2 final questions I'd like folks to focus on, if you could. One, related to your last remark, Stein. Is this technology superior to what you think, evolution of sort of legacy-based systems would allow for the development of 2 of the most important use cases for 5G, which are Internet of Things and autonomous vehicles, as you just talked about? Is the flexibility innate to open systems a superior way to get to where we need to be on some of these applications of the future? And the other question that I think Doug will especially want to comment on is, what sort of policies do we need from Washington, maybe from our allies, to allow this technology to develop in the ways that you all have described? So
yes. So I'll start, but then I'd love to hear from Bob, because Bob has been involved in doing a lot of the advanced automation on the Rakuten networks, and Cisco has been establishing a lot of this flexibility. So if 5G is all about sending your tweets faster there's no point in deploying it, right? Let's just face it. Or if it's about doing what you're doing right now only with your smartphones, okay, it'll go a little bit faster, but so what, right? If it's about like sending an email and your email gets sent a tenth of a second or 100th of a second faster than now, or even 2 times faster than now, it doesn't really matter. The potential and the opportunity we have at 5G is to start using the wireless networks in new and unforeseen ways. And not only these public nationwide systems, but also small systems, portable systems, field systems for the government use, systems within your campus, whether you've got some factory, whether you've got the port of LA and you want to take care of that, and so on and so forth. The systems, the large integrated systems, have been optimized for one particular purpose, which makes them very difficult typically to be able to change. And we saw that, for example, with E911. That's a longer story, but E911 was the requirement that when you took your phone, right, and you made a call, your network was supposed to report the position of the caller, right? And it took 10 years for it to be deployed. And then even to today, E911 doesn't, the requirements have been watered down to the point that it takes, you only need to supply the position within 6 minutes of a caller calling. So anyhow, the bottom line is that purpose-built, whatever they are, telecommunication networks, computers, surgical instrument, construction instrument, when it's purpose-built and it's all vertically integrated, it's very inflexible. It's very difficult to change it beyond what its purpose was originally designed for. Software-based modular networks, much easier to automate them, much easier to rescale them, to change them, to morph them into completely new forms. Maybe Bob can talk a little bit about the work that Cisco has been doing in this space, which is really ahead of the curve of what the traditional infrastructure vendors have been deploying.
Bob, let's go to you then. Doug, we'll go to you for some reflections on policy that would promote these technologies.
Sounds good.
Great. Yeah. And thanks, Dean. I think you nailed it too. 5G is about the new use cases and doing things differently, and things that, quite honestly, we can't fully anticipate today either. We don't know what all those use cases are going to be. And when you look at that, I think there are 2 key aspects to this. As you look at supporting IoT, which was your example, Tom, there is certainly the software-based programmability and the flexibility that it's allowed there, and then the automation that you can bring in to automate these workloads, because now the radio system is software, and you can automate the instantiation of it. You can have APIs into those systems that allow easy access, so you don't have these months-long OSS and BSS integration cycles just to add a new service, or years-long sometimes service delivery cycles. So I think those are really key aspects of it. And the other piece is just the modularity of being able to place the functions in the right position based on the service you need. So if you need something that's going to be an ultra reliable, low latency connection, as they say in 5G terminology, then you have the ability to push things closer to the edge of the network and out there, to where the interactions happen much more quickly. Or if you want to move that further back into the network and get greater scale out of it, and you can't do that with monolithic systems either. And that's where the real power is not from saying, hey, I have this thing, and now I want to replicate that thing exactly with software and hardware and just disaggregate things. That's interesting to some extent, but I think that's what we've been trying to do for a while with virtualization. And now what we have the ability to do is do things completely different. As you move them to software, then you can imagine completely new ways to deploy these services. And that's where the real win comes in, and we're seeing it in a number of different customer opportunities.
Okay, excellent. Thank you. Doug.
Sure, yeah. So I think it's been a fantastic panel. Learned a lot. But yeah, a few thoughts on some of the opportunities to try to policy opportunities to try to accelerate this transition. I think this is like sort of a general framing. It's like as we've touched on, right? It's like we're in the midst of this transition. It's incredibly complicated with different parts, right? There's some trade-off to performance depending on maybe your time to market or particular applications that you're hoping to get out of the network. To my mind, it's like these big, complicated transitions like this, you always want to have, a distributed market making those sorts of decisions. This is not somewhere where you'd want, simply government coming in and saying, new 5G networks are going to be, open specifications in accordance with O-RAN Alliance or something like that, right? So you don't want the government, any sort of policymaking body, forcing this transition or making it happen sooner than it would under more natural circumstances, if that makes sense. But I do think that there are real opportunities to help accelerate it. So obviously, one that comes to mind is more R&D and more test beds. And here I'd point to the I believe it's the USA Telecom Act that would allocate a chunk of money for grants and for test beds of this nature, as well as form an advisory committee and a number of other other roles. Absolutely, this makes sense, right? It's like we want money to go to make sure that there are test beds that can scale up opportunities around open radio access network equipment and try to identify real challenges, problems especially with scaling that up to large service area. Get those identified and overcome those problems as they come up. Ideally, to my mind, the money allocated for that purpose would be coming from general treasury funds rather than from auction revenue. But that's sort of like a whole separate issue that we don't need to get into now. I do worry there's a lot of conversation around this rip and replace effort that being led by the FCC. There's also some language in the USA Telecom Act to this effect that would encourage or require those operators removing Huawei equipment, replace the new equipment with openly defined interfaces in compliance with the O-RAN architecture. I do worry that this may go too far, and especially when we're focused on essentially what are tier 3 rural operators, that the benefit that we gain is relatively small, right? It's like that it doesn't touch a large population of the network. We don't see a really large scale transition from that. So the benefit, to my mind, is relatively small, and to force this on some of the smallest cellular operators in the U.S. to try to undergo this difficult transition and work with new systems integrators, things like that, I worry that would be challenging with little benefit, and we'd be better off trying to encourage this otherwise natural market transition. When it comes to these test beds, I think it makes sense to rely on existing projects. And here, I think it makes sense to look at the Platform for Advanced Wireless Research. It's a program initially seeded with grant money from NSF. I believe it's now run or led through a program called US Ignite in partnership with Northeastern University. And so there is already this work. I think it makes sense to be running these sorts of test beds through this open infrastructure to get a better sense. At the same time, it's like, as I mentioned, there are a number of existing commercial trials and actual deployments already underway. But I still think, more R&D that we can continue to pour into, general advanced wireless systems, the better. And if it is done through this Platform for Advanced Wireless Research, I think that would do well. One idea in particular that I'm excited about that I haven't seen a lot of conversation around, and it might be because of this sort of split between the telecom policy world and the manufacturing policy world, but I do think there's a real opportunity to work through the Manufacturing USA program. So this is operated by the Interagency Advanced Manufacturing National Program Office within NIST. And it aims to bring together industry, academia, and public sector as well to try to work on policies that would increase U.S. competitiveness facilitate technology transitions, and this is a perfect example of that to my mind, as well as boost advanced manufacturing workforce within the United States. So to my mind, a new institute that's focused on this type of equipment that could bring together different industry partners, operators, with some of these small manufacturers that are trying to focus on this particular type of equipment, and really work with a coalition to try to scale up the manufacturing of the devices and overcome this challenge where you have large incumbent operators trying to purchase equipment, and in some cases, from at least on the actual radio side, right, from very small companies that are trying to get started in this space. So I think Manufacturing USA program is an opportunity that deserves a little bit more attention. But yeah, to my mind, it's like, don't make technology requirements up front. Rather, we should be working to encourage, to nudge along this transition that's already going through the market today.
Okay, I think we've more or less run out of the time that we had asked our viewers to stay with us. So I'm just going to summarize by saying that I think this has been an excellent discussion. And to me, the key takeaway is that this new set of technologies offer a real opportunity to move this industry into a more flexible, innovative future, and that much of this work is now being deployed, and much of it is being deployed in places like the United States, in Europe, and in Japan, and that there's a bright future for this technology. So let me thank our audience for staying with us. Let me thank our panelists for incredibly incisive insights to this, and I hope you all have a good day. So
thanks, Tom. This is great.
Okay.